if Einstein was alive today, seeing the progress that we are making in quantum, what would he think, and what would he still keep on arguing that this is? Because initially I know that he was not very, I mean, averse towards quantum and all that. He said, no, it's not possible, and all those things, until that Schrodinger cat experiment came in front of him, right? So, as far as I know, maybe you can elaborate on it more. So, if he was alive today, how would he see that? I mean, what is your thought on that?
Yes, I mean, yeah, definitely. Whatever you said is absolutely correct. Even the Schrodinger, I mean, Schrodinger, who gave the wave nature of this, I mean, the mathematical wave treatment, he even didn't like the idea of this entanglement at one point. Okay, so what you are talking is all about the entanglement. Okay, entanglement means, I mean, if I'm having two electrons which are far apart, it does not matter whether it's in Earth or the other particle is in Mars. If I change the state of one electron, the automatically it will change the other state of the electron. Okay, and in other ways you can say that if I'm having an entangled pair, let's say both the spins are up. So if I'm having up spin, I can 100% know that you are also having an up spin. The moment I change the direction of the spin, I am 100% sure that the spin at your end has changed. Okay, so this is called the entanglement. Again, in the I would say that in the nature, this quantum nature is inherent in inherent in the surroundings. For example, if you might have heard of twins. One of the twin is sitting here, the other twin is in some other place. If he gets sick, the other twins also get sick. I'm not talking about all the twins, but mostly it happens. Okay, so you can say that they are entangled. Okay, whatever happens to the first guy, it will happen to the other guy. Okay, the same things. I mean, similarly, you can think of the electrons having this entanglement. Okay, so what Einstein actually did not like the idea. It's a famous paradox which is called the EPR. Einstein was one of them. Boris Podolsky, and then Nathan Rosen. Okay, EPR. So what does EPR says that it says that you are that it violates the principle of, there are two principles which is violating. The entanglement theory is violating two principles. One principle is called the principle of locality. So what does principle of locality says? That you cannot transmit the information faster than the speed of light. Okay, for example, if this is spin up, it has to spin up. If it is going spin down, so the process of transferring this information is impossible. That means you are challenging the whole theory of relativity, general theory of relativity. Other thing is that if you are changing this from up to down, this is also changing. Does not matter whether it's in Mars or this is in Saturn or it is in some other planets. Okay, so that means you are violating the principle, the local principle. That means the environment can be changed only by the mere presence of the closest interaction. Okay, that means I can change this spin only when if there is certain disturbance that has happened here. You cannot change arbitrarily. I mean, some disturbance have to be there due to that changes happen. This is what principle of locality. The other principle that he challenges the principle of realism. Okay, so that means when you are saying that this is how this is spin up, this is also spin up, that means there is a property which is already inherent. You cannot predict on something which is 100% sure. Okay, when you are turning this down, this is also turning. That means you are predicting 100% that it will be turning down. That means there has to be a hidden variable. That has to be a hidden variable which is unknown to us, still unknown to us. Okay, so he did not like the. So it's false to say that Albert Einstein did not like the idea of quantum mechanics. He did not have problem with the concept of quantum mechanics, but he challenges that the quantum mechanics is some form of an incomplete formalism. Okay, that means we are missing some hidden data, hidden variables. This is what he was all unhappy about. But later in 1960s, I believe, major big experimentalists like there's another called Bell's inequality. These two people came up with the experimentals and theoretical foundations, and they clearly say that quantum mechanics is a full theory. Whatever theory we know it's totally full. There is no hidden variables associated with quantum mechanics. Okay, and that was clarified later. That was clarified, and then I believe actually this quantum computer was coined by Richard Feynman. He gave to MIT. He was presenting some of his work in a conference at MIT in 1981. There he first talked about that to understand the nature of to understand the nature or the quantum nature, you have to get a quantum computer. So this is actually the date from where people have started focusing on the quantum computers. Okay, so it has huge applications. I mean, now it does not matter who likes it, who does not like it. It's coming in our way. Okay, but frankly speaking, the computers which we are using, the classical computers, the quantum computer is not going to replace the classical computer. Many have a wrong notion that it will take our jobs. It will take the no, it's not going to take the jobs. Okay, it's coming because to make our life easy, because now we are, even in India we are having 1.4 billion people. 1.4 billion people means so many datas. Classical computer cannot handle those. Let's say you are keeping a track of other data. Okay, some people are coming, some people are dying, some people are forging. So many things can possibilities can happen. Classical computer cannot keep track of all these things. Okay, all these priorities. Okay, but quantum computer, since it has a principle of, it can use the principle of superposition and entanglement, it can happily deal with this kind of complexities. Is it clear?
Yeah, yeah. So quantum
Yeah.
computing is a necessity for India, if I understand you correctly, and the way the population is growing to handle the data and all that. So it's a necessity for the future.
By the way, India has progressed a lot on this quantum. It has recently quantum computer with 25 qubits they have generated. Okay, India. China is leading us. China has now at present. China is having playing with 500 qubits, or maybe they have a program increasing from 100 qubits to 500 qubits. USA got on these quantum processors or Sycamore processors. They already started with 54 qubits long time back. 2019 they declared the quantum supremacy. I think Google, but IBM, Google, Microsoft, these are now the big players. Okay, so for the quantum computing, I mean, it's a fact, Sudhir, that country who is having a more percentage of GDP invested in research, they are going to get the final game, or they are going to get the final laugh. Okay, so quantum computing does not come free of cost. It's a huge investment. Both government, both private players have to come together, okay, and have to deal with it. That this is what USA, UK they are doing. You see all the developed countries, they have their they have their negotiations with AI. They are coming, they are making shaking hands with this quantum computing, these nuclear energies, AI, nuclear energy, quantum computing. They are all doing this in a partnership mode. Okay, so India should not lag behind. I mean, India have a huge talent of engineers and physicists, so, and chemists, scientists basically. And I believe India is going in a right way.
Yeah, yeah. So, but India. I mean, the infrastructure needs to be a little bit improved because we are not a very research-oriented society, and historically we have not been very good in doing researches and coming up with new products and technologies. But things are changing, and hopefully for the better. Uh,
Correct,
Who
correct,
knows?
correct, 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 correct.
So, last question of the day, and I
Yes,
need your one-word answer for this. Okay. So, if quantum
sure.
mechanics is a movie, which genre would it fit best? Is it a mystery? Is it science fiction, comedy, or a scary movie?
I mean, okay. I mean, since you wanted a one word, I would say science fiction would be a good one. Okay, but again, a combination of comedy. It can be in superposition state. Okay, comedy and science fiction both. Okay, serious and this is what quantum mechanics is about. I mean, always in the superposition state. Why not here also? Comedy and seriousness both. Okay, but yeah, I mean, this is what the today's youngsters have to look for. I mean, yeah, if you want to understand quantum mechanics through a movie, through a comic show or through some simple experiments. Do it, go for it. Okay, so this scientific department needs to build up within this young community. I mean, young students, just not rushing for marks for clearing these competitive exams. This won't work. Okay, I mean, all the developed countries are developed not for the reason. I mean, not for a reason that they are having high quality. The high quality students does not need to have a good marks. Okay, I mean, you can have if you have a scientific department, if you can think on a problem, particular problem, you can do much better.